Okay, so to draw a Lewis dot diagram, essentially this works because an octet is equivalent to an NS-NP configuration. Okay, so we know there can be up to 2 electrons in the s orbital and up to 6 in the p orbital, and 2 plus 6 equals 8. So 8 electrons max. Okay, so essentially the Lewis model works really well for when we have elements where the valence electrons are either in the S and or P block. So remember, this one is the S block and this one is the P block. Okay, so when we write Lewis symbols, we're essentially looking at periods 1 through 3, and we're writing out the NS-NP valence electron configuration and ignoring the core configuration. Okay, so we're going to use the group numbers. Okay, so group number 1 will always have just one valence electron because that is corresponding to an NS1 configuration. Okay, group 2 is always just going to have 2 valence electrons. Okay, so that is corresponding to an NS2 configuration. I'm using N because N can be 1 through 7, right, depending what period it is in. Then groups 13 through 18, in terms of their Lewis structure, we are going to label these 3, 4, 5, 6, 7, 8. Okay, because so you just like take off those 10d electrons. We don't care about those because those are going to correspond to NS2 and then NP1, NP2, NP3, NP4, all the way up to, sorry, it's not going to fit font-wise, to NP6 configurations. Okay, so if you had, for example, fluorine is in group 17, so that's telling you there's 7 out of a possible 8 electrons. So we draw fluorine like this with 7 dots around it. Can I find something nice to do a dot? Possibly 1, 2, 3, 4. Okay, they're not going to be even 5, 6, 7 dots around it, representing its 7 valence electrons because fluorine has the helium core configuration. Don't care about core. And then it's going to be 2s2, 2p5, and 2 plus 5 gives me 7 valence electrons, which corresponds to its Lewis symbol. All right, so helium and hydrogen are weird because helium and hydrogen only have what's called a duet. Why? Because they only have one s shell, and we know that s shells can only fit up to 2 electrons. Okay, always this way, right? All right, so helium then is in group 8, okay, or yeah, stimulate. So this is the one you've got to be aware of, okay, that it is just going to be 2 dots in the Lewis structure because it is an exception because it's only got a 1s2 configuration. So always be thinking about the actual configuration. Now, the order we draw these dots, you just got to make sure if you've got 4 or less that you're spacing them out. So see how I did these 2 dots opposite each other? I could have done them to the left and the right. Doesn't really matter, but the point is they are opposite each other because we are trying to symbolize the fact that electrons like to spread out because electrons repel other electrons, right? Opposites attract and same charges repel. Okay, so that's how we draw the Lewis symbol for helium. Okay, let's see what else we got then. Okay, aluminium. So aluminium down here. Where's my little drawy thing gone? All right, so aluminium is going to be 3 dots in its Lewis symbol because it's in group 13. So I'll just draw aluminium and then 3 dots around it. Make sure I spread them all out because there's 4 or under. So 1, 2, 3, like that. Don't be tempted to pair them yet, okay? Because pairing electrons costs energy. So remember, in terms of electronic configuration, that is corresponding to the neon core configuration. And then 1, 2, 3, S2, 3, P1. Okay, so if in doubt, write out your electronic configuration and the valence electron count should equal the number of dots you've drawn, right? 2 plus 1 is 3. Okay, that's how you know you are good. Okay, let's just do one more because these are fairly quick and easy. All right, nitrogen. Okay, so find nitrogen on the periodic table. Nitrogen is here. Okay, so group 15 means there should be 5 dots in its Lewis structure. Okay, so I'm going to draw nitrogen. And this is great timing because I want to show you what you do if you have more than 4. So 1, that is a dot, I promise. Let's try it again. 1, 2, 3, 4, and the fifth one is going to have to be paired. So I'm just going to put it on the bottom because I've got more room there. Okay, so that would be the Lewis symbol for nitrogen. Okay, so to write the core configuration is going to be helium. Oh, stop doing that. I need to remove that button and clean the coffee out from under it, I think. So that'll be 2s2, 2p3. 2 plus 3 is 5, so there's 5 electrons around the nitrogen. So see, this is why it's such a great model for covalent bonding. We're going to get there really soon because it does model how many valence electrons those elements have.